Hey folks, so today we're going to look at 8.3.4 and we're going to do the derivation together and then we're going to kind of play around and see what happens. All right, so in 8.3.3 we came up with the angle sum and difference formulas. Here's the combined form up here. We're going to use that to help us today to come up with what are called double angle identities and half angle identities. Should be super. All right, so 8-130. So the double angle identity for sine is derived directly from the angle sum identity for sine of A plus B. So sine of A plus B. That's the one we're going to use. Okay. So we're going to rewrite sine of 2A so we can use the angle sum identity to expand it out. Well, sine of 2A is equal to sine of A plus A. Right? So what we can do is use our angle sum identity for sine to work this out. So sine of A plus A equals sine of A times cosine of A plus cosine of A sine of A. Which, let's be real, folks, we can simplify that. Those are literally the same thing there. So you can write 2, let's go cosine sine. Boom. That's how we're going to approach it. Sine of 2A equals 2 cosine of A times sine of A. Bam. That's kind of fun. I think that's good times. So let's move on. Now we're going to create the double angle identity for cosine using the same thing. All right. Well, cosine of 2A again can be written as cosine of A plus A. So we're going to use the cosine sum part. Remember, it's plus here, so we're going to use minus over there. So let's do that. All right, so now let's apply that. So cosine of A plus A equals cosine of A times cosine of A minus sine of A sine of A. And that's kind of good, except for me messing up that O there. Let's rewrite that. It's cosine squared A minus sine squared A. Boom. So something you should notice right now, this looks familiar and it's close. That's almost the Pythagorean identity, except the Pythagorean identity is different right here. This should be a plus for the Pythagorean identity. When it's subtraction, as we have here, then it's the double angle identity. So it's a small little thing, be aware, just kind of see those different things. But there's two other ways we could mess with this. Speaking of the Pythagorean identity, which is cosine squared of x plus sine squared of x equals 1, we could use that to rewrite the cosine double angle identity in two different ways, to give for a total of 3. It all depends whether we solve for cosine or sine. So if I solve it for cosine, I get cosine, that kind of shows up, cosine squared of x equals 1 minus sine squared. I feel like I should have done it in green, too late. If I solve for sine, I get 1 minus cosine squared of x. Now, depending which one we use, we can get two different things from this. So what if I substituted in for sine? I would get cosine of 2a equals 2 cosine squared of a minus 1. Again, to see that, we put that part in for sine. So it was minus parentheses 1 minus cosine squared of x, or of a. And by doing that, it flips the sign on that. So it'll be minus 1 plus cosine squared of x, or of a in this case. And that's how we were able to combine it into that. There's a bunch of random marks here. I'm going to clear up a couple. I'm going to change to green because I think green's going to, oh yeah, it shows it a little better. So let's see what happens here. What if I substitute in 1 minus sine squared for cosine? Let's see what happens. I get cosine of 2a equals 1 minus 2. Let's try that again. 1 minus 2 sine squared of a. Because when we substitute it in for cosine, remember, it's going in right here. So I get 1 minus sine squared of a. The 1 stays positive. But then we have 2 negative sine squareds of a. So that's how I get 2 negative sine over there. Sweet. So between, let's highlight all 3 of them. So here's one version, second version, third version of the cosine double angle formula. And again, we just have that because we have something sine and cosine squared, which allows us to have multiple things. But we're going to do a little bit more with that. The one in particular that I really want to focus on is this bad boy, the cosine of 2a. All right, that's going to give us a half angle identity. And this one's also going to give us a half angle identity. And half angle identity means, like, if I have an angle that's half some other known angle, I can exactly evaluate it. Like, I know what pi over 6 is for sine and cosine, but what about pi over 12? Can we evaluate that exactly? Yeah, because it's half of pi over 6. Big brain kidneys. So let's look at 133. So the first thing we're going to do, we're going to start off with cosine of 2x equals 2 cosine squared of x minus 1. And let's solve for cosine squared. Well, that's not going to be that bad. We're going to add 1, divide by 2. So I get cosine of 2x plus 1 divided by 2 equals cosine squared of x. This is useful in Calc 2, especially for reducing powers on things. That'll make, I mean, it doesn't seem like that, but a useful thing, but it really is when we get into things called like finding antiderivatives. Cosine squared, it doesn't really have an antiderivative straight up, but if you turn it into cosine of 2x plus 1 over 2, that has an explicit one. So technically cosine squared does, but it's not immediately obvious until you switch it. But that's not for now. That is for when you make it to Calc 2. Not necessarily Calc BC, but Calc 2. Okay. So if we let a equal 2x, then we'll solve for x. Oh, no. Let's write a equals 2x. If we solve that, we get a over 2 equals x. Why is that helpful? If we take this and substitute it in over here in this equation, all of a sudden I get cosine of A plus 1 over 2 equals cosine squared of A over 2. All of a sudden, we have an angle divided by 2. To finish this off, we should just square root both sides. So we get plus or minus the square root of cosine of A plus 1 over 2 equals cosine of A plus 2, A over 2. So this is the half angle identity for cosine. Note there's a plus or minus out front. Most of the time when we do a plus or minus, it means that there's two possible answers. In this case, that's not the situation. In this particular situation, the plus or minus means that we have to look at the context, look at the original angle, see approximately where the half angle is, and decide if it should be positive or negative. All right, so this is more of a decision than saying, hey, there's two answers. No. There's one answer. We just have to put the plus or minus in there to account for the possibilities. All right. Now let's do this for sine using the other cosine identity. So we have cosine of 2x equals 1 minus 2 sine squared of x. So if we do the same thing we did, we can subtract 1, divide by -2, which will give us, let's see, we can write it like cosine of 2x minus 1 over -2 equals sine squared of x. And for our mutual benefit, let's distribute this negative from the bottom, kind of everywhere, redistribute it. So it looks like this. 1 minus cosine of 2x over 2 equals sine squared of x. Using that technique we did earlier, saying let A equal 2x and do A over 2 equals x, we can take that and substitute it in here, which gives us 1 minus cosine of A over 2 equals sine squared of A over 2. And then we square root to get plus or minus the square root of 1 minus cosine of A over 2 equals sine of A over 2. Again, the plus or minus here does not indicate there are two answers. It means that you have to look at the situation and decide, do I need another, or is it positive or is it negative? So you have to make that conscious decision. Is it positive or is it negative? There we go.